Welcome back to Project Pulse. In this lesson, we are going to focus on the gray shaded area in the cash flow waterfall. That's our operating expenditures, or OPEX. Up to now, we have spent a lot of time building the revenue side. Now we will see what it actually costs to run this battery. If you're new to this Deal Lab series, I recommend starting with part 1, where you can download the modeler start file for free and build the model alongside me. Link is in the video description below. On the integrated financial statements, you can see the operating cash waterfall. In the last lessons, we populated the top line revenue section. The next step is to bring in OPEX so that we can get from revenue down to EBITDA. Everything we'll build in this lesson will eventually flow into these OPEX lines right here. But first, let's step back for a moment and look at how we structure operating costs in this case study. We group OPEX into 4 blocks. The first one is fixed costs per megawatt AC per year, cost items that scale with alternating current capacity. The second block is fixed cost per megawatt hour DC at the beginning of life, costs linked to installed DC energy. The third block are fixed costs per year in US dollars, site level fixed costs that don't scale directly with installed capacity. And the fourth block are variable OPEX. In our case, this is just a land lease as a percentage of revenue. For each line you see the unit, the index we use for escalation, and a short description. These definitions will guide the inputs in the model. Now let's move back to the checkpoint file from our previous lesson. And for now we'll start focusing on our first block. Here you can see the same per megawatt cost items and the base year values we've just discussed. These are our cost assumptions before inflation, assuming 2025 is our base year. The first line item is our balance of plant long-term service agreement. This is a full scope O&M for transformers, switchgear and yard. Our second line item are ops and remote monitoring, covering costs associated with control room monitoring and dispatch support. Our third line item covers our energy management system and software as a service license. Those are costs for our software platform fee for the energy management system. And our last line item for this block covers station service energy. These are energy costs for our heating and cooling system, controls and parasitic loads. So now let's move to our operations sheet and actually start integrating that first block. And down here is our operating expenditure section, and we will now model the first 4 row items, which are in the unit of US dollars per megawatt AC. At least that's the unit how our inputs are given, and the output for this row is actually in thousands US dollars. So that's something to keep in mind. So let's start modeling these 4 cost items, and the first thing we will do is pick up our input from our inputs time independent sheet. That's G276. We will anchor this to our column only, so hit F4 1, 2, 3 times. And then we will multiply this with our megawatt on an AC basis. So we will have to scroll up to our power section and look for this value. And our gross AC power at the point of interconnection is given in cell G47. So let's actually pick up this input coming from the inputs time independent sheet. We can fully anchor this value with F4. And then we'll also multiply this with, let's scroll up, our actual operations flag right in row 12, because we only have to pay OPEX if we actually operate the battery. Hit F4 1, 2 times. And that should give us our cost in US dollars. Because further down here we are given the input in US dollars, which means if we want to return thousands USD, we also have to divide by 1,000. So just divide by 1,000, hit enter, drag this down for 4 rows, hit Ctrl D and drag it over Ctrl R. And before applying inflation, we pay over the asset life $60 million US for our balance of plant long-term service agreement, a relatively minor cost for remote monitoring and software licenses, as well as 14 million for station service energy. So those two cost items are actually quite significant. The other two will not move the needle too much. So let's move on to our next block. Let's move back to the inputs time independent sheet. And the next two cost items we will model is our BESS long-term service agreement, which is typically a warranty and performance package provided by our original BESS supplier. And the second cost item in this category is our insurance cost, which covers property and business interruption. So let's move back to the operations sheet and actually integrate those two cost items as well. And first thing we will do is again pick up our input. In this case, $3,000 per megawatt hour on a DC basis. Let's anchor this to the column only, hit F4 3 times, and then we will have to find that megawatt hour DC on a beginning of life DC basis. That was given in our IM, so let's make sure we actually pick up our installed megawatt hours at beginning of life. That's how the contract is structured. Let's scroll up. And the DC energy at beginning of life is given right here in cell G66. Hit F4 once. And this cost basis will essentially not change even after our augmentation is scheduled and took place. And that's just how the case study assumes the contracts are structured. In the real project, the cost might increase even further after an augmentation has taken place, but in our case, we do assume that it's always linked to our original DC energy at beginning of life. Then we'll also have to multiply this with our operations flag again, row 12, hit F4 2 times to only anchor to the row. And then again, we'll have to divide by 1,000 since the input was given on a US dollar basis. Hit enter, drag this down one cell, and let's move those two guys over to the right, Control R. And you can see that these two cost items are really significant, especially our BESS long-term service agreement as well as our insurance. And the reason being is mainly that right now we have case 5 activated, and case 5 is a 4-hour battery, which means that our installed DC energy at beginning of life is relatively high in comparison to the other cases, which inflates these costs quite significantly depending on how many battery cells are actually installed. Let's see how this cost item shakes out when we turn on case 15, which is a fully merchant case with a 1-hour battery. And you can see that then these costs drop quite significantly, because now we assume a 1-hour duration instead of a 4-hour duration. All right, now let's move on to our remaining fixed costs, which are given down here. And this US dollar per year block captures site level costs such as scheduling and ISO fees, site level ops and monitoring, software licenses, spares and minor repairs, as well as admin and compliance costs. And finally, we also model our RPO premium from our previous lesson right here. And that is the annual fee we pay for the revenue put option in our merchant and RPO case, which is indeed case 15. So make sure you have case 15 on for this one. And you can see if you hop into cell H177, this is referring to H157, which is only active if we have inputs for case 15 right here. So if I were to switch to a different case, say case 1, you will see that we do not have any costs for our RPO premium. So this is already all set up. And let's switch to case 15 to ensure that we actually have our RPO premium OPEX right here. All right, let's move back to the operations sheet. And let's hop into cell K282, where we will again pick up our input in column G282, hit F4 1, 2, 3 times. And these items are modeled very easily because they're given in US dollars. So we just multiply them with our operations flag up here, hit F4 2 times, and we can divide them by 1,000. So our output is in thousands USD. Copy this, paste special formulas. So hit Alt H VS F to only paste formulas. F, hit OK. Let's drag this over, Control R. And you can see that all of these costs are relatively minor, except our RPO premium is quite significant. And let's actually really watch out what we're doing here with the RPO premium, because our RPO is only relevant during the actual RPO tenor. So let's take off the reference to the operations flag and actually multiply this with our RPO flag, which is in row 242. Hit F4 2 times, hit enter, because obviously we only want to pay the RPO premium during the actual RPO term. And you can see that after 15 years, that expense drops. And that's it for our fixed OPEX. So we can take the sum of all of these rows above, drag them over, Control R, and that gives us our operational expenditures before inflation for our fixed costs. Then we also have to model our land lease, which is basically just 2% of our total revenue. So that's fairly simple as well. We take G291, hit F4 once to fully anchor it, and let's multiply this by our total revenue, which we calculated in the previous lesson. And here we pick up the total revenue in row 260, which includes already the haircuts we would assume. Hit enter, and let's drag this one over, Control R. And here we only have one variable cost item, which is our land lease, but we still take the sum of the above. So let's drag this one over as well, Control R. And that allows us to move on to our total OPEX after inflation. So right here, we basically just pick up all the OPEX items we have modeled up here and apply the underlying inflation assumption. Some of the OPEX items are inflated at CPI, others at the OPEX assumption, and others don't have any inflation. And the index assumptions or inflation assumptions you can find in our inputs time dependent sheet. Our CPI index starts with 3% and then slowly decreases to 2.5% and 2.25% per year. And our OPEX index is slightly below, which starts at 2.5% and then drops down to 2% and 1.75%. So let's move back to the operations sheet and actually pick up all of these indices. And we'll do this by simply linking it to our real cost, which starts in row 276, and then multiply this with an X lookup. And the lookup value is given right here in column G, which is coming from our inputs time independent sheet, where we can select the escalation assumption via dropdown. Let's anchor this only to the column, so hit F4 3 times, comma, and let's scroll up. And this list right here is given in column D, 23 to 28. Let's fully anchor this one, hit F4 once. And the result vector is gonna be right here, which we only anchor to the row. So hit F4 2 times, comma 0 and comma 0 for an exact match. Close parentheses, hit enter. And then before we drag it over, we also have a sensitivity flex right here in column H. So we'll multiply this entire formula with 1 plus our sensitivity, which will anchor 3 times. So hit F4 1, 2, 3 times to anchor to the column, close parentheses, hit enter. Let's double click right here and you can see that our OPEX sensitivity will be modeled in case 20, where we inflate OPEX by plus 20%, which is why we want to make sure that we pick up this sensitivity flex right here. Make sure you also get the anchoring right. So let's copy this one, drag it down with Control D. Let's skip land lease for now, because if you hit F2 here, you can see that we wouldn't refer to our actual land lease here, but instead to our total fixed OPEX. So make sure you're not mistakenly making an error right here. And then we take all of these guys, drag them over, Control R. And you can see, for instance, for the RPO premium, nothing has changed because we don't assume any inflation. But for the balance of plant, a long-term service agreement, the actual cost has increased quite a bit from 16 to 20.2 million after applying our OPEX escalation. Then let's finish this section with our land lease expense as well. And this is going to equal to our land lease expense in row 291. So pick up K291 times X lookup. The lookup value is again here in column G. Hit F4 1, 2, 3 times, comma. Our lookup array is going to be up here. Hit F4 once, comma, and the result vector is the same again. F4 1, 2 times, comma 0, 0 for an exact match. Close parentheses times open parentheses 1 plus our flex. So let's scroll back down and pick up our sensitivity flex. Hit F4 1, 2, 3 times. Close parentheses, hit enter and drag this one over, Control R. Great. And we don't apply any inflation here, but nonetheless it's important that we get the core logic right. Here we do apply inflation, and you can see that the reference here is moving as expected across the sensitivity and escalation assumptions. Then let's take the sum of all of these guys here, drag it over, Control R. And you can see that we have total fixed OPEX of 85 million plus our land lease expense, making a total sum of 92.3 million before inflation, and after inflation, that's going to be 107 million US dollars. So then the last thing we can do is model our average power unit OPEX cost, similar to what we have done for our revenue section, where we modeled our average power unit revenue in US dollars per kilowatt AC per month. And here we do the same for our OPEX with the same unit. So we can actually compare revenue and OPEX within the same unit terms. And to do this, we will have an if error statement again. And if error, our total OPEX right here divided by, let's scroll up. And let's make sure that we use the same gross power capacity as we did in the last lesson, just so we actually compare apples with apples. And in the last lesson, we picked up row 55. So make sure you pick up row 55. Hit F4 1, 2 times, comma 0, close parentheses. And this cost item was given in kilowatt AC per month. So we will have to divide by months per year and multiply by 1,000, since these are 1,000 USD and this is US dollar per kilowatt AC month. Hit enter. Let's drag this one over, Control R. And you can see that in our first operational year, we have costs of our operational costs of $2.19 per kilowatt AC month and revenues of 6.85, which means we should have a positive gross margin. Then let's move over to our integrated financial statements. And you can see that now we don't only have the top line revenue section, but also our OPEX line, which already automatically calculates our operating cash flow. So out of 336.9 million revenue, we get 230 million operating cash flow after subtracting 107 million total OPEX after inflation. And just to double check, this sum here should equal the sum in our operations sheet, and it does. So that's great. All right, guys, and in the next lesson, we will move on to our capital expenditures, which we model down here and which sit one level further up in the cash flow waterfall, where we will actually model our uses of funds, which are our capital expenditures. And that's the money we will have to pay up front to actually build our asset. All right, guys, I will see you in the next lesson. See you there.